Hello, welcome to MathSci Hub, where we tackle past grade 11 and 12 question papers. And so far, we have finished question 1 and question 2 of both grade 11s and grade 12's question papers. Actually, I think mostly it's question 1 in question 1 and question 2 in grade 11 and question 1 in grade 12. So today we move to another topic in the question paper, and which is number patterns. So number patterns normally covers question 2 and 3, or in some cases question 2 and 4 of your question papers. And I'm going to start with grade 11 number patterns and move on to the next session covering grade 12 number patterns, because even though some of the formulas are the same, there are some added formulas in grade 12 number patterns. So I'm going to start first by going through some of the formulas, or some of the formulas that you guys are going to use. But remember, these formulas are provided to you it's part of your worksheet that comes with the question paper. So there's no need actually to know the equations by heart, but then you must know when or which formula you need to apply, and in what cases those equations actually do work. So I'm gonna start with, like I said, number patterns, grade 11 and grade 12. Number patterns, but let me start with grade 11 first. Like I said, there are different formulas that actually apply when you deal with number patterns, and we are going to look at linear or arithmetic sequences, and as we move on, we are also going to look at quadratic sequences. Let's quickly go through the formulas that are going to be used and that are given in your question papers. But remember, if you have in a linear sequence term 2 minus term 1 equals term 3, let me just fix my t's. Term 1 equals term 3 minus term 2. Meaning, if you minus term 1, if you minus term 2 to term 1, and you get the same value if you minus term 3 and term 2, you should be having equal numbers, and we call that a common difference. We call that common difference. We call that common difference. Common difference. We call that common difference. Now, in a linear sequence, there's a formula that you need to apply, which is Tn plus, Tn equals An plus B, or alternatively you can apply Tn equals A plus N minus 1 and then D. Let me just quickly go through what these variables represent. You know your A in your sequence will be your first term, and then your D will be your common difference, right? So guys, I'm just quickly explaining these because you are busy with your exam, so I'm not going to go deep into detail. I'm just making you aware of the equations that we are going to be using. Now the quadratic sequence is a n squared plus bn plus c. Now the difference between these two equations is when you look for the common difference in a linear sequence, the first difference applies, meaning looking for that you get a constant number between your terms in the first difference. But then when you come to a quadratic sequence, your first difference will not give you a constant, right? But then if you do a second difference, you will get a constant number between the terms. So that's the difference between those two equations, which is linear and quadratic sequence. Now guys, let's quickly jump into the question papers. As you can see on the heading above, we are doing grade 11 paper 1 2015. Alright, we are going to look at question 3 because this is a continuation from the past 2 weeks question papers. So question 3, question 3 says given the linear pattern (5, -2, and -9, and then -289. Now the question says 3.1.1, write down the constant. So guys, I'm just going to abbreviate some of the words so that we can save ourselves some time and some space. So write down the constant first difference. Write down the constant first difference of what we are given there. Let me change the color of my pen. Now remember, the first difference would be, let me just quickly write it down. For you to get the first difference, you will need the first 3 terms of your sequence, and as you can see here, we are given the first 3 terms of our sequence, so we can easily determine the first difference there, the constant first difference, meaning is -2 minus 5, which is -7. Moving on to the next one, we have negative 9, yes, is it negative? Yeah, it's negative. It's negative 9 minus 2. Guys, one of the mistakes that are normally common is when you do this, beware of the sign. When you try to find whatever second difference or first difference, always be careful to actually check your signs, because they are really important. You might get confused if you're looking for the first difference or even the second constant difference, that nothing adds up. It might be that you forgot to check the sign of whatever term that you're dealing with in that sequence. So it's very important to check the sign. Now in this case we have minus 9 minus 2, which in this case will give you negative 7. So your D will equal negative 7. That's an easy one to mark for you. So let's move on to the next question. Now it says it's 3.1.2. It says write down the value of term 4. Write down the value of term 4. Now if we go back to our sequence, right, and you check on how you got from, let's say, negative 2, you said 7 plus 5, which is negative 2. Now how did you get from negative 9? You said negative 7 and a negative 2, right? Now we need to find T3, which is the same. You just, this is T3. Now they want you to find the next term, right? They want you to find T4, right? Now how do we find T4? You add again negative 7 and negative 9, which is what? Negative 16. Meaning now your, let me just check, meaning your term 4 will equal negative 16. You simply added negative 7 because that's your constant difference, and negative 9. So to explain this, you just added your constant difference to the subsequent term of your sequence, right? So in this case you added negative 7 to the negative 9, which will give you your term 4, which is negative 16. Right, let's move on to our next question. I'm just gonna clear this off the board. Actually, let me clear everything out so that we have some space to continue. everything out. And look at the next question. The next question says, let me just write it down, it's 3.1.3. It says, see, calculate the number of terms in the pattern. Calculate the number of terms in the pattern, right? Now for us, what they are looking for in this case, remember, this is what? This is a linear pattern, right? Meaning what should come to mind is, which formula am I going to use? And we are going to use this formula, an tn is equals to an plus b. Now what are they asking us? They are asking us to find the number of terms, which is n. But for us to find the number of terms, what do we need? We need the value for b. We need the value for b, right? Now how do we get the value for b? We get the value for b by saying you can choose to add or to substitute any term in your sequence, right? Let me choose the 5. Let me choose the 5, or let me just write it down here so that I won't have to go back to the slides. Let me write my sequence again down here, which is 5 and -2 and -9 and -289. Right? Now what you need to do here is, let me choose my first term, right? Let me choose my first term. So I'm going to say T5 equals my A. What is the value of my A? My A, like we said, is your first term. In this case, our first term is 5. Our constant difference, sorry, it's 5. It's -7, sorry, it's -7, right? And then I choose term 1 plus b. Remember, term 1 has a value of 5, meaning I'm going to write my 5 and then say -1 into what, -7 times 1 plus b, and this is obviously -7. You take the -7 to the other side, it will give you positive, meaning your b will equal 12. Your b will equal 12, right? Now, since now you have the value for b, remember the question says calculate the number of terms in this pattern. Now this pattern goes all the way to what? To 289. Now in like, let's say you don't have a formula for whatever reason for this, in a normal way, what you would do, sorry, is since you have your common difference, you would just add -7, -7, -7 again until you get to 289, and then add those terms separately and check and count them. Actually, how many terms do I have? One more thing, when you're dealing with n, your n, whatever value you get for n, it should always be a positive integer. Should always be a positive integer, meaning you will, if your answer is a fraction or a decimal, your n will not be a correct answer. Now, meaning, remember, we're dealing with number patterns. We are counting something. We are counting things. Now, if you count things, you can't count negative things. You can't say you have negative. You have, someone asks you how many apples you have, and say you have -2 apples. You can't do that. When you count something, you count something as a whole, meaning your n should always be a positive integer. It will never be a fraction. It will never be a negative, because you're counting whole things. I hope that makes sense to you guys. So you always have a positive number of terms, meaning your n will always be a positive integer or a positive whole number. You will never have a negative, or if you have a negative, it's invalid in that case, meaning whatever you have as your answer, maybe they said calculate the number of terms. If one of the values for n is negative or it's a fraction, always write NA, or just cross out the equal sign where that n is negative, or that n is a fraction, or a decimal number. All right, moving on. Let me just continue on the question that says you must calculate the number of terms. Now, you are given a formula, so it makes our lives a bit easier. We don't have to count each and every term all the way to -189. So meaning we can just easily or quickly use our formula, right? Now remember, we have found b to be 12, right? And according to our formula, we can just say, remember, this is the number, this is the terms that we have. It goes all the way to 289th term. 289th term equals, in this case, your a, which is -7, and then we are looking for n, plus our b, which is 12. You can take the the 12 to the other side, and then say 289 minus 289, and then the 12 is going to change the sign and be a minus as well, and then you add them, you will get -301 equals -7n, and then you divide throughout by 7, because we are looking for n. You divide by -7 actually, because the sign in front of the 7 is negative. So your n will equal -301 divided by -7, which, if you type it in your calculator, if you punch it in, it will give you 43. So the number of terms between the number of terms in this pattern that we were given, we have 43 terms in between those terms. We have 43 terms that are in our sequence. That's how this question should be interpreted in a way. So moving on to the next question. on to 3.2. To 3.2. Okay. 3.2. Now they say a linear pattern. I don't know what happened there. Let me just change my marker to white again. A linear pattern has a difference of 3 between consecutive terms, meaning one after the other, and its 20th term is equal to 64, meaning T20 is 64, right? Now the question says, the question to our state to that statement says, determine the value of T22, meaning you will start counting from T20 and then try to get T21 and T22. But now remember, you are given what there? What is given there? You are given the difference between the terms. They say the difference between the terms is 3, right? And then T20 equals 64, right? You are given T20. They say you must find T21. Actually, you must find T22. So meaning before you go to T21, you must get T21 and T22. And you are given the difference, meaning you can just say from T20, what I have to do is add the 3 to get to T1, and then add another 3 to get to T22, in which case it will give you 64 plus 3 plus 3, which is 70. Nice and easy marks for you. Let's move on to the next question. All right, moving on to 3.2.2. It says, which term in the pattern will be equal to 3 T5 minus 2. So So which term in this pattern will equals to that? So meaning they want us to find what? They want us to find n. They want us to find n. For us to find n, we have to start first with what we are given and what we know up to so far. Sorry, what are we given or what do we know? We know T20, right? And then we know our A, right? Our A in this case is 3. Our A is 3. Let me just remember our A is what? Our A is our difference, in this case is 3. Hence I say our A is 3. And then this is what they want us to find. And then we have our B. This is our normal linear equation. We know the value of T20 is 64, right? And then we are trying to find what? We are trying to find B in this case for us to be able to solve. Now we substitute the value, your term, which is 20, your n, which is 20, plus B, and then you simply just calculate there. 3 times 20, 60 is going to be 64. 60 plus B, you take the 60 to the other side, your B will equal 4. Your B will equal 4, right? Now after finding your B, we go back to what the question requires. They want to know which term in the pattern will give you T equals will be equal to 3T5 minus 2, right? We have managed to find our B, meaning we can go back to our equation and say, to this equation and say 3T5 minus 2 equals 3n plus B, right? And then from here it's just straight substitution. In this case we will have 3 and then close bracket 5 plus 4 minus 2. Let me just bring it closer. It's plus 4, it's minus 2, close bracket, and then if you calculate that, should be 3 times this is 15, and then it's 4 minus 2 is 2, 30 times 3, you will get 55. Now from here you say T20 equals 3n plus 4, and we just did our T20, which is 55, let me just clear this part. Which is 55, and then from here you can see, before I confuse myself, it's 3n plus 4 equals 55, and then you take the 4 to the other side, you are left with 3n equals 55 minus 4 is 51, and then you divide by 3, and then your n should give you, if you say 51 divide by 3, your n should give you 17. Your n should give you 17. Alright, actually that is not the end of it. There's 3.3.1, which says now consider the quadratic pattern, consider the quadratic pattern 5, 12, 29, 56, dot 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 dot. Now the question says write down the next two terms of the pattern. Write down the next two terms of the pattern. Write down the next two terms of the pattern. Now the key to this question is, now you are dealing with a quadratic pattern, meaning you need to find what? Your second difference, right? Now let's deal with that first. It's 5, it's 12, it's 29, and then it's 56. Let's find our first difference. It's 12 minus 5, which is 7, and then it's 29 minus 12 is 17, and then we have 56 minus 29, which is 27, right? Now you can check it for yourself. Is there a constant difference between these terms? Is there a constant term between these terms? Between these terms, there isn't, right? Between these terms, you can check it and say 17 minus 7, which is 10, and then 27 minus 17 is 10. Now from here, you can clearly see that for you to get the second difference, the term for the second difference here, what you need to do is just add a 10. Just add a 10. So if you say 27 plus 10 will give you 37, right? Now for you to get this term, what do you need to do? You add both of them, right? You add both of them, right? And say 37 plus 56, which is 93, which is 93. Now again, remember you found your second difference, which is 10. Just add a 10 here for you to get the next term. It's 47, right? Now again, what do you do? You add again and say 47 plus 93, right? You say 47 plus 93, and then remember, for us to get the second term in this, we said 56 plus this, and then for us to get the next term, we said 47 plus 93, which is 140. So your answer for the next two terms of that pattern, of that sequence, is 93 and 140. 93 and 140. All right, let's jump over to our next question, which says prove that the first difference, let me just write it down. Question 3.3.2, it says prove that the first difference of this pattern will always be odd. Meaning, what do you need to prove then? You need to prove that first difference in that pattern, whatever you have, it will always be odd, meaning it won't be a whole number, right? It won't be a whole number. All right, remember, let's take T1, our first term, and try to calculate our B, right? Our B, we are taking the first term, right, and try to get our B, which is, yeah, we're looking for B. Now our T in this case is, let me just go back, our T for the first term, this is B. Our T for the first term in our first difference, right? In our first difference it's 7. In our first difference it's 7. Meaning it will be 7 equals 10 times 1, which is 10, plus B, and then your B will equal, if you take it to the other side, will equal minus 7. Now our general formula for this is Tn equals to 10 minus 3, right? This is our general formula for this. right? Now let's try to find a sequence for this term, right? A sequence for n, for the number of terms. Now if we try to find the sequence, meaning we are going to add maybe 4, 5, 6, 7 all the way up, and then whenever we add that, we also need to minus it to what? To a 3, right? So let's start. Let's say we have as our general pattern, our general equation says a 10, and then let's say we take term 4, right? And then we minus a 3, right? And then I'm gonna do that to the next term again, which is term 5, right? And then I minus a 3, and then I'm gonna do the same to the next term again and say 10 minus 6 times 10 times 6 minus 3. This is all derived from our general formula, right? And let's start with this first. Let's start with the first one and say 10 times 4 minus 3. What do we get? We get 37, right? And then say 10 times 5 minus 3. What do we get? We get 47. And say 10 times 6 minus 3. What do we get? We get 57, right? Can you see, using that general term and having our minus 3 there as our b, whatever term that we add from the first term all the way to whatever term, and you still have to minus the 3, you will always end up having a 7, because whatever we do, we're still gonna minus with the 3, right? And what is a 7? 7 is your odd number, right? Meaning your answer is, all answers end with the 7. All answers end with a 7, which is an odd number, right? That's our answer. 7 is an odd number, and all numbers are going to end up with a 7. That's the end of that question. And from this, we are done with question 1. We are done with question 1. Let me just double check. We are done with question 3. This was question 3 actually. This was question 3. This was question 3 that we just dealt with, and we are going to deal with question 4 next. We are going to deal with question 4 of that very same paper. Let's deal with question 4, and then we look at 4.1, which says consider the quadratic pattern 3. Let me just move it up. 3, 5, 8, 12, ... and then they say, determine the value of T26. Now there are a few things. There's actually one thing that I need to run by you guys. Now when we deal with linear sequence and then we're trying to find our A will be what? The first difference, right? That's when we deal with linear sequence. When we deal with quadratic sequence, your A will be the first difference divided by 2. The first difference divided by 2. The second difference, sorry, let me just rewrite, it will be your second difference divided by 2. It will be your second difference divided by 2. Now let's get our second difference in this equation, in this sequence, right? We have 3, 5, 8 and 12. 5 minus 3, which is 2. 8 minus 5 will give you 3, and then 12 minus 8 will give you 4. Our second difference in this case will be 3 minus 2, which is 1, 4 minus 3, which is 1. Now, meaning our A will be 1 divided by 2, which is a half. 1 divided by 2, which is a half. Now that we got that out of the way, let's move to our formula, right? Because they are asking us to determine the value of T26, right? T26. Now our formula for a quadratic pattern, for our quadratic sequence, is an squared plus bn plus c, right? Now, in order for us to find the 26th term, right? Remember, we have a formula for everything. We have a formula for us to actually make life a bit easier for us, right? Now, in that formula, there are variables that are unknown and that you need to solve, right? Now, for you to get to T26, there has to be known variables, right? In order for you to calculate to get that number of terms, right? Now, for us to get there first, we need to find out the values of those variables that are in our quadratic sequence, right? And then I'm gonna walk you through the steps because there's different methods of doing it. So I'm gonna start walking you through the steps and explaining as we go along, right? Now we have determined our A, right? And then we have this B that is unknown, and then we have the C, which is unknown, right? And what they are asking us to find is the value of T26, right? And we have these unknown variables. All right, so what we need to do here is try to find the values of this variable so that we can use our equation fully in order to find T26. All right, so let's do that. I'm gonna write down our sequence down again. I'm gonna write down, let me start with my equation. Tn is equals to an squared plus bn plus c. Remember we calculated our a to be a half. Now they're asking us to find T26, but before that we need to find what B is and we need to find what C is, right? How do we do that? In our sequence, which is 3, 5, 8 and 12, you can choose any of those values in that sequence. Let me choose T3, which is our term 1, right? T3, which is our term 1. And then remember we had a half as our A, and then remember I chose term 1, right? And then again I'm going to substitute the n because our n is 1. Our n is 1. C plus b times n, I'm just going to write it as b alone, plus c. Remember here it is squared, so let me just not forget to square it there. And what is T1? T1 is 3. So I'm going to say 3 equals a half plus b plus c, right? And then I'm gonna try to make the c subject of the formula and leave it alone on one side and take everything else to the other side, meaning I'm gonna have c equals negative b. And then if you say 3 minus a half, then calculate it on the side, because if we move the half to the other side it's going to be a negative. So we're going to have 2, and then we're going to have 6 minus 1, which is 5 over 2. So meaning we're going to have minus b minus, it's positive 5 over 2. And I'm going to go on and call this my equation 1, right? And then let me choose T2. T2, it has a value of 5. It has a value of 5, right? Let me go ahead and say T2 equals a half, and then T2 is, remember, is 2 plus 2b plus c, and then my value for T2, as you can see, it's a 5, equals 2 plus 2b plus c. We take the 5 to the other, the 2 to the other side, we are left with 3 equals 2b plus c, and I'm gonna go and call this equation 2. Now you might ask, what is the purpose for all of this? The purpose for all of this, remember, we are trying to find those unknown variables, and the only way to find two unknown variables is solve them how? Simultaneously. That's how we solve two unknown variables. So you applied each and every math skills that you have been taught up until this far, and then remember, you've dealt with simultaneous equations before, and you know one of the when you need to solve two variables that are known, the only way, or some of the ways to solve them, is by solving them simultaneously. So that is what we are going to do here. Like I said, we are going to, just go back and see my slides. Like I said, I called this equation 1 and then I said this is equation 2, right? And I'm going to substitute C, the value of C, into equation 2, right? Into equation 2. So wherever I see C into our equation 2, I'm going to put this, right? I'm going to put that. So let's start. We say we substitute 1 into 2, meaning we are going to say 3 equals 2b minus b plus 5 over 2, and then from now on we can just solve for b. We take the 5 over 2 to the other side, and then on this side we are left with this 2b minus b, which is b, and then 3 is going to be a minus 3 minus 5 over 2 is over 1 times by 2 over 2. It's going to be 6 minus 5 over 2, which is a half. So your b will equals to half. Your b will be a half. Now that we have found the value for b, let's get the value for our next variable, which is c. Our next variable, which is c. Remember, in one of the equations, c was equals to minus b plus 5 over 2. So we just take what we know for b and substitute it, right? Meaning we are going to have c equals a half plus 5 over 2. A half plus 5 over 2 is equals to 6 over 2. Is it 6 over 2? You'll see, yes, it's 6 over 2. It's a half. Just double checking and see if I substituted correctly. Oh, it's minus, sorry. Remember here it's minus, so it's minus a half. So it's minus a half. So it's going to be minus, so it's going to be 4 over 2, which is c will equals to 2. Your t will equal 2. Now that we have found the value for b and c, we can simply use our quadratic term in order us to find T26. So let's find T26. So I'm gonna say T26 equals, remember our a, we had a half, and then we are looking for 26, right? So meaning our n will be 26 squared plus a half 26 plus 2. If you calculate this, say 26 squared and then whatever you get there you divide by 2 or you multiply by a half, which will be 338, and then 26 times a half will give you 13 plus 2, and then you simply add those together, and then you will find the value of T26 will be 353. Meaning if you go from the first term, term 1, term 2, term 3, term 3, and remember our first term is, it was 3, 5, and then 8, and then 12. I'm gonna say this is T1, and then this is T2, this is T3, this is T4, right? And then you go on and on and on and on and on up until T26. Your value for T26 will be 353. All right, that's question 4.1. Let's move on to question 4.2. 4.2. It says a certain quadratic pattern, a certain quadratic pattern has the following characteristics. Right? When it says T1 equals P, T2 equals 18, and then T4 equals 41, and then T3 minus T2 equals 10. Now they say determine the value for P. Determine the value for P, right? Now, how do you approach this? Because you might be, and don't be thrown off by variables that are thrown into the sequence. What you do is just do your normal operation in terms of sequence, and if you understand the normal operations in terms of sequence, you won't be having a problem or be thrown off by variables which are thrown into your sequence, right? Just as long as you know the normal operations, and then you understand which formula to use under what circumstances, whether it's linear, whether it's sequence, arithmetic, or otherwise. Just don't be thrown off by variables, right? So let's break it down. Let's break this down, and then T1 in this case it's P, right? T1 in this case is P. T2 it's 18. T3 in this case they say it is what? T3. I'm just trying to get back to what we are given. Oh, there it is. T3 in this case, they say it's, we are actually not given T3, so but then T3 they say it's whatever T3 is minus T2, which is equals to 10, right? Which is equals to 10. And then we know T3, and then we know T2. T2, what is T2? T2 is 18, right? And then they say this is equals to what? This is equals to 10, right? How do you get T3? You just say T3, and then you take the 18, which we know it is T2, to the other side. And if you take it to the other side, it's going to change and be a positive. And then your T3 would be 28, right? Let's go back to our sum. Where is it? There it is. So T3, like we just calculated, would be 28. And then T4, they say it's 4T1, right? They say it is 4T1. That is T4. That is T4, right? And then what do we know for T1? We know T1 is what? They say it is P. So you can say T4 it's equals to 4P, right? It is 4P, right? And after doing this, you need to find your second difference, right? Second difference, and we can say T2 minus T1 equals T3 minus T2, right? Now from this we can say 10 minus 18 close bracket minus P equals 4P, which is this, minus 4P minus 28 minus 10. From here we can just simply calculate our P. We can simply calculate our P. On this side we have a 10 minus 18 plus P equals 4P plus 28 minus 10, and then we can just simply take the P to the other side, take this P to the other side, meaning we're going to have 5P, take the 28 to the other side, and then take the 10 again to the other side. And on this side, remember we still had 10 minus 18 minus 28 minus 28 minus 10. So on this side it's negative, so sorry, it should be negative here, right? So let me just do it like this. It's negative 38. This is everything from this side, right? It's negative 38, and then if we take the negative 38 to the other side, it will be positive 38. It will be positive 38, and then 5P 5p will equals to, it's positive 38 plus 10 is 48 minus 18, which is 30. Remember, we are looking for p, so you divide by 5, you divide by 5, and then your p will equal 10. That's how we find the value for p. And that ends our question 3 and 4 in the 2015 paper. Hopefully this was helpful for you guys, and we are still going to cover question 3 and 4 of 2017. Alright, let's look at the next question paper, which is November 2017 question 3. Question 3, 3.1. It says, given the finite linear pattern (12, 17, 22, 22, and then it should say ... all the way to 172. Now it says, the question, which is 3.1.1, it says determine the formula for the nth term of the pattern. Now pattern, it's 12, 17, 22, all the way to 172. Now remember, they say you must determine the linear pattern. Now in this case, you are given whether what type of number pattern you're dealing with. So it's linear, meaning you can go ahead to use your linear equation, which is Tn equals An plus B. Now what should be our next step? Our next step is trying to find the value for B. How do we do that? You can actually choose any term in your pattern. Now I'm going to start, I'm going to go ahead and choose term 1 of my pattern and say term 1, T1 equals An plus B. Now we know term 1 to be 12, so I'm going to go ahead and say 12 equals our A. Did we determine our A? No, we haven't. So let's go ahead and do that, because our A is the first difference. So in this case, what's going to be our first difference? Let me just write it down here so that it can be all clear. 17, 22, ... 172. Our A is our what? The first difference. So it's going to be 12, 17 minus 12, which is 5, 22 minus 17 will give you 5, meaning this is our value for A, and then we can go ahead and write A, and then remember we chose the first term is term 1 equals B. Sorry, we just found the value for A, which is 5, so we can go ahead and write 5 in space of A and then calculate the value for A. For B, 5 times 1 is 5, and then we take the 5 to the other side, which will give us B equals 7, because it's going to be 12 minus 7, so your B will equal 7. Your B will equal 7. Now determining the formula, since you have found the value for B, will be Tn equals, remember your 5, your A is equals to 5, and then N plus, we just found B to be 7. So that would be your formula for the nth term of the pattern. I hope that's clear to you guys. The first one was nice and easy. Alright, let's look at 3.1.2, which says calculate the value for T12, right? Now, calculating the value for T12, we want to find the value of the 12th term, right? That's basically it. Find the value of the 12th term. So let's do that. We're gonna say T12 equals 5, which is our A, and then the 12th term plus 7, and then you can just say 5 times 12, 5 times 12 equals 60 plus 7 would be 67. Meaning, if you start counting from the first term, which is 12, third term, which is 17, third term, which is 22, and you go on and on and on and on until the 12th term. The 12th term will be T12 would be 67. That's how you actually try to interpret your answer. So it's much simpler if after writing it, after writing your answer, try to conceptualize it, because you can clearly understand something if you are able to conceptualize whatever you're writing or whatever your answer is. Don't just write your answer, but then try to conceptualize it. So they want you to find a value for T12. So you say, I have three terms, and I have the values for those 3 terms, and then they want me to calculate the 12th term. So go on and say the first term is this, the first term is this, the second term is this, and then all the way to the 12th term. That value for the 12th term is what I've just calculated, which is 67. Now looking at the next question, which is 3.1.3, and then it says determine determine the number of terms, the number of terms in the pattern, they want you to calculate the number of terms in the pattern, right? Let me start on the clean board. And then we know this clearly said this linear pattern is infinite, meaning it ends, and they've given us the value of the last term, which is 172, right? So let me start by writing down my formula, which is Tn 5n plus 7. Now they want us to calculate the number of terms. They want us to calculate n in this case, right? And we know our terms, they go all the way to 172, which is equals to 5n plus 7. If I take the 7 to the other side, it's going to be 172 minus 7, which is 165, equals 5n, and then I'm going to divide throughout by 5, and then n would be 33. So those are the number of terms that you have in that linear pattern, Now moving on to the last part of this question. Which says, given the first 4 terms of the linear pattern, and those terms are 3x, y, 30. So these are the first 4 terms of the linear pattern, right? Now they say determine your x and your y. Now what you need to do, like I said the last time, don't be thrown off by the x's and y's, because if you know the order of operation, or what are the basic requirements in solving the linear patterns, the number patterns, you should be able to do this and not panic at all by being thrown away by the variables that are in the question. Now in this case, we don't know what x and y is, right? Now you can find your x and y by saying, in a linear pattern, what is the first step that I do? It's try to determine the first difference, right? Alright, let's look at 3.2, which is the last part of question 3. It says, given the first 4 terms of a linear term, of a linear pattern, x, y, 30. These are the first 4 terms of this linear pattern. Now the question says determine x and y, right? Determine x and y. Now guys, what you shouldn't do here is panic or try to be confused by the variables thrown in the question, because like I said before, the variables might throw you off and then you might be confused what to do next. But then if you know the order of operations, so to speak, on how to do or operate any number pattern, the first step that you should know on this part is try to determine your first difference, right? So let's go ahead and determine the first difference. The first difference in this case, I'm gonna try to label my terms here on the top and say this is T1. Let me get a different marker. I'm gonna go ahead and say this is T1, this is T2, this is T3, this is T3, and then this is T4. This is T4. And we know for the first difference we should have a constant number, and we determine that constant number by saying T1 minus T2 minus T1 should equal T3 minus T2, and then again T4 yeah, should be T4 minus T3 should equal T3 minus T2, right? That's how we determine the first difference. Now in terms of this pattern that we are given, it means we are going to say this minus this term minus this term minus this term. So let's go ahead and do that. So we are going to say x minus 3 equals y minus x, right? So I'm gonna try and isolate this x equals, meaning I will need to take the x to the other side, meaning it's going to be y equals, if I take it to the other side, we are going to add it to this other x, meaning we are going to have 2x minus 3, right? And again I'm gonna say T4 minus T3 equals T3 minus T2, meaning I will have 30 minus the y equals y minus x. Again I'm going to try to isolate my y and take it to the other side, and then in return take the x to the other side, meaning I'm going to have 2y equals, sorry, it should be a minus here, not an equal sign. 2y minus x plus 30, x plus 30. Now guys, can you see now we we have managed to create a situation where we have two variables of which we don't know the values of, two unknown variables, and we have learned before that the only way, or one of the ways to solve two unknown variables is by using simultaneous equation. So we're gonna go ahead here and try to find the values for y and x by solving them simultaneously. So I'm gonna go ahead and say this is my equation 1, and say this is my equation 2, and say substitute 1 into 2. So let's go ahead and substitute equation 1 into equation 2. So let me quickly just rewrite it down. Equation 1 is y equals 2x minus 30. This is my equation 1. Equation 2 is 2y equals x plus 30, right? This is equation 2. So if we substitute 1 into 2, meaning wherever we see x in equation 2, we are going to put this here, right? We are going to put this expression, this value, so to speak, for y. So let's go ahead and substitute 2, and then we have a y in our equation 2, meaning we are going to say 2x minus 30 2x minus 30, or sorry, it should be 3. It's my mistake. It's my mistake. It should be 3. Let me just double check. Yeah, it should be 3. Should be 3. And then it should equal x plus 30, right? So let's go ahead and distribute, meaning we are going to have 4x minus 6 equals x plus 30. If I take this x to the other side, it's going to be 4x minus x, which is 3x, and then I take the 6 to the other side, we will get 30 plus 6, which is 36, and divide by 3, 36 divided by 3 should be 12, meaning x equals 12. Now, since now you have found the value for your x, if you need to find the y, you can substitute that x in either of the equations, right? So I think this one is the much easier one to substitute your x. So let me go ahead and say y equals 2, substituting the x, which is 12, minus 3. Your y equals 24 minus 3, which should be giving you 21. Now question 4 of the same paper, like I said, 2017 November. It says, given the quadratic pattern given the quadratic pattern two 44 193 148 109 dot, and then the question says write down, it's 4.1. it says write down the next term of the pattern, the next term of the pattern. Meaning if this is term 1, this is term 2, this is term 3, and then this is term 4, they want us to write down the next term, which is term 5. So they want us to write the next term of the pattern, which is term 5. So they want us to find the value for term 5, right? Remember now, you are given that you are dealing with a quadratic pattern. Now if you have a quadratic pattern, remember now, we not only finding the first difference, we finding the second difference, because the first difference will not be constant, meaning you have to find the second difference, which should be constant, meaning you will be dealing with a quadratic pattern in this case, right? So let's go ahead and find our second difference. It's 148, it's 1, so it's, sorry, it's 244 1 193 148 and 109. So let's go ahead and see the first difference here. 193 minus 244, 193 minus 244, it's minus 51. 148 minus 193, 148 minus 193, minus 45, and then 109 minus 148 minus 148 should be minus 39. Can you see these numbers? They are not constant, so we need to find our what? Our second difference. Our second difference, we should be minus 45 minus 51. Now you should be paying attention, right? It's minus 45 minus 51. Why? Because we have minus 51 and we still have to minus, meaning here it is going to be positive, so it's going to be negative 45 plus 51, which is 6, Similarly, 39 minus 45 is going to be 39, negative 39 plus 45 would be 6. So this is our second difference. This is our second difference. Let me check this off. Now determining the next term in the pattern. Since now you've established what your second difference is, which is positive 6, just take the positive 6, put it in the next value, right, that you have in the first difference, right? Meaning you will say negative 39 plus 6 should give you negative 33, right? Now after doing this, for you to determine the next term here, what do? You simply add the negative 33 to the 109. That's when you will find out what the next term is. Now why do I do that? If you can follow how your second term was determined in this pattern. Your second term was determined in this pattern by saying 244 minus the first difference. 244 minus the first difference should give you 193. And you go on in that order, right? Now the next term here, the last value for this term is 109. And then we've determined the next value in our first difference in this pattern to be negative 33, because we added the negative 33 to the positive 33 to the negative 39, which gave us negative 33. Now we determine the next term by saying 109 minus 103. Let's go on and do that and say 109 minus, not 103, minus 33, which should give you 76, right? So like I said, they want us to determine T5, right? So your answer should be T5 equals 76. T5 equals 76. I hope you guys understood that. So let's move on to our next question, which says, it's question 4.2. It says determine the nth term of the pattern. Determine the nth term of the pattern, right? Now what do we know? We know we are dealing with a quadratic pattern. We know that we are dealing with a quadratic pattern. Now they want us to determine the nth term, right? Meaning they want us to determine what Tn. They want us to determine Tn, right? Now given that you've been told that it's a quadratic pattern, what should come to mind? My quadratic pattern formula, right? Which formula are we going to use? we are going to say Tn equals an squared plus bn plus c, right? Now remember, first thing that you should try to check is we don't know what A is, we don't know what B is, we don't know what C is in this case, right? Now, how do we determine C in the quadratic pattern? We determine C in the quadratic pattern by saying your second difference divide by 2, right? Now in this case we determined our second difference to be what? To be 6 divided by 2, which meaning our A should be 3. Now that's how you determine the A in a quadratic pattern, right? Remember, in a linear or arithmetic pattern, how do you find it? Is the first term of the first difference. But then in a quadratic pattern, you say the second difference divided by 2 should give you your A. Now what are we left with? We are left with B, and then we are left with C, right? Now let me just quickly write down my pattern, which is 24 it's 24 it's 24 244, sorry, it's 193 193 and then 148 and then 148, 109 and 76. Now remember, this the first difference is minus 51 minus 45 minus 39 and then minus 33. Our second difference, remember, we had 6 as our second difference. Now you can take any term. Now in this case I'm going to take the first term. And say T in the first term equals, I've already determined my A to be 3 into 1 squared plus B, remember the N is 1, plus C. Now the value for T1 is 244, so I'm going to straight ahead say 244 equals 3 plus B plus C, and then I'm going to take my 3 to the other side and say 241 equals B plus C. So again, I'm going to try to isolate one of the variables. Let's take the C and say C equals, and then I take the B to the other side, minus B plus 244, and I'm gonna go ahead and call this my equation 1. Remember, again, in this case we are going to deal with two unknown variables, which are B and C, meaning I can go ahead and try to solve them simultaneously. So again, I'm gonna choose term 2 to try and manipulate my second equation. T2 equals 3 into 2 plus 3b plus c plus c plus c, right? Remember, my T2 is what? It's 193. So I'm going to say 193 equals 4, 2 squared. It's going to be 4 times 3 is 12 plus 3b plus c, right? And I'm going to take my 12 to the other side. I'm going to take this 12 to the other side. So it's going to be 193 minus the 12, which is 181. 181 equals 3b plus c, and I'm gonna go ahead and say this is my equation 2. This is my equation 2, right? And as you know, solving simultaneous equation, you must substitute one equation into the next. So let me just quickly rewrite my first equation. It's 141 minus b, which is equation 1. Equation 2 gave me 181 equals 2b plus c. So my next step should be substitute 1 into 2, meaning wherever I see c, I will put this in there, right? Meaning I'm going to have 181 equals 2b, right? 2b plus 241 minus b, right? So as you can see here and here, so it's 2b minus b, which is b, and then if I take the 241 to the other side, so here is going to be 2b, and then what is the value for my b? If I take the 241 to the other side, we will have 181 minus 241, which is minus 61. Sorry, we should, so it's 2b minus b, so it's only b. If we take the 241 to the other side, it's minus 241 plus 81, which is negative 60. That's what we get for b. Now let's find c. Let's find c, and I'm going to choose this equation 1 and say c equals 241 minus we just determined b to be minus 60, meaning we're simply going to add these two, which will give us 301, which is our value for c, right? Now that we have determined the value for a, the value for b, the value for c, we can go back to our equation. Let's go back to our equation and say Tn equals 3n squared, right, minus 60n plus 301 minus 301. So that should be your answer. This should be your answer, right? Let's move along to the next question. All right, let's look at 4.3, which says which term in the pattern, which term in the pattern will have the value of 508. Now remember, we have determined our nth term in the pattern, our quadratic pattern, right? And then we ended up with Tn equals 3n squared minus 60n plus 301. We ended up having this, right? Now they want us to determine which term in the pattern will have this value, right? Right, meaning whatever term, which is that term, is this, which is 508, right? Now they want us to determine that term. What is that term? That term it's determined by n, and then they gave us the value for that term, which is what? 508. Meaning we can continue and write the 508 as the value of our term which they want us to determine, right? They want us to determine which term, right? Meaning if I have T1 as a particular, which has a particular value, and T2 which again has a particular value. Actually we do have the values, sorry, let me just write them down. We know T1 to be 244, and then T2 to be 193, and then T3 to be 148, and so on and so on. Now we have a particular term which has a value of 508. That is what they want us to determine, that particular term, right? Meaning they want us to determine n. Now how do we do that? Let's just continue from here. So it's 508 equals 3n squared, which is unknown, minus 60n plus 301. So we can take the 508 to the other side and equate everything to 0 and say 3n squared, 508 minus 309, 60n, 508 minus 301 should give you minus 2 207. Let's try to simplify this by dividing everything throughout by 3, meaning we are going to be left with n squared minus 60 divided by 3, which is minus 20n, and then 207 divided by 3, which is 69. It's minus 69 equals 0. Can you see now we have a quadratic equation, meaning we can try to find the factors of n. Now in this case, remember here 69, so 69 is 23 plus 23 plus 23, it's 69. So we can say here, let's have a plus 3, and then there let's have n minus 23. Those are our factors for n, meaning your n equals -3 or your n equals 23. Now remember when we started with number patterns, we said we are dealing with counting things, right? And then you can never count negative things, right? Or you can never count a person as a half a person on Apple or whatever. We count whole numbers, we count whole things, meaning whatever value that you have for n, it should never be a negative or a decimal number, meaning in this case, since we have two values for n, which is -3 and 23, n will not be equal to -3. This one is not applicable, meaning your value for n is 23. So that term in the pattern which has a value of 108 is term 23. Term 23. I hope that makes sense to you guys. So let's move on to 4.4, which says between which two consecutive terms of the quadratic pattern will the first difference be 453? Which two consecutive terms will the first difference be 453, right? Now, what should come to mind? You need to check the type of question that is posed to you. Now they say the first difference, meaning whatever equation that we are going to use, it must be a linear or a linear equation or an arithmetic equation, right? Which is given by Tn equals a plus n minus 1 into d, right? Now going back to our pattern, which is 244, let me just go back to the slide. Let me just go back to the slide and see what I have. Let's see, actually let me just write it all down. Now let's go back to our pattern. It's 244, it's 193, it's 148, and then 109, and so on and so on. And then our first difference in this case was negative 51, negative 45, and negative 29, and so on and so on. Now they want us to determine the two consecutive terms, right, of which the first difference will be 453, right? So in that term, that value will be 453, right? And then what is our A? The first term of the first difference, right? Which is minus 51. Minus 51 into n minus 1, and then our second difference, which is D, we know that should be 6. So I just forgot to add a plus there. And then let's say 453 minus is 51, which will be 51 plus, if we distribute the 6, if we distribute the 6, we should get 6n minus 6, 6n minus 6, and then we add these two. Is minus 57, so it's 453 equals, if you take the 57 to the other side, it's minus 57, it's going to be positive 57, so it's going to be 453 plus 57 actually it's minus, so it's 453 minus 57 43. If we add the 7, so it's 453 plus 57. If we add these two, so it's minus 51 minus 6, so it's minus 57. We take the minus 57 to the other side, we will get 510 equals 6n. So we try to find n, so n is 510 divided by 6, which is 85. So meaning that term which has the value of 453, is term 85, right? So consequently, the term that follows the 85th term is term 86. So that's your answer. Those two consecutive terms are T85 and T86. So if you manage to determine the one term, you should know the key says consecutive terms, meaning if you determine that one term, it should be obvious that the next term should be whatever numbers that follows. So if we determine 85 to be that term which has the value of 453, and then determining the next one simply says 85, and the next one should be 86. Now that concludes our grade 11 revision in terms of question papers that we've just covered in number patterns, and hopefully we've managed to actually explain everything, and I hope when you write your exams, grade 11s, everything will be clear. And we are going to move to grade 12's number patterns and try to do the question papers and walk you guys through each and every question.